It has been 2 years since NASA's James Webb telescope gave us a stunning first look at the depths of our universe.
Proxima B. And so what's the story? And that it's Earth-like.
Yeah, so that's not what's interesting about it, because we've got plenty of Earth-like planets, and the total catalog of planets ever discovered now is more than 3,000. So what makes Proxima B interesting is that it's an Earth-like planet orbiting the nearest star to the sun.
The James Webb telescope ultimately identified Proxima Centauri B as being 7 trillion miles away, and recently made an astonishing discovery: distant glimmers emanating from the planet that strikingly resemble city lights on Earth. Could these truly be signals from extraterrestrial life? What if humanity's greatest discovery is just within reach? Through the lens of our state-of-the-art observatory, we delve into the mysteries of Proxima Centauri B, uncovering astonishing findings. While exploring the vastness of space, our telescope detected strange lights emanating from Proxima Centauri B, a distant star beyond our solar system. Prepare to be amazed as we unravel the enigma of these extraterrestrial signals. The lights bear a similarity to what we see when we look at cities at night on Earth, raising the exciting possibility that there may be an extraterrestrial metropolis on this far-off planet. Scientists are ecstatic about this prospect because it may be the breakthrough they have been waiting for. It raises the question of whether sentient creatures exist, and if the earliest indications of their existence may already be in front of us. They may even be existing in ways that we haven't yet considered. A scientist noticed the lights flickering at unusual intervals as the data streamed in. Was it mere coincidence or an intentional signal? The team debated fiercely, each flash raising fresh questions. Meanwhile, concern grew over the mission to investigate, which was now at risk due to technical challenges. The world watched with bated breath, wondering if we were on the verge of discovering we're not alone in the universe. NASA experts were astounded that such distant lights had been detected. They couldn't help but ponder how long these signals had been shining, unnoticed, until our technology advanced enough to reveal their presence. Columbia University astronomer David Kipping has made observations on this planet's complexity because of its special interaction with its star, Proxima Centauri. Proxima Centauri B seems to behave differently from typical rocky planets, which absorb sunlight and emit heat. The intriguing element, though, is that this discovery goes beyond the simple observation of lights in space. It also demonstrates how crucial the James Webb Space Telescope is to our understanding of the cosmos. It not only raises the prospect of life beyond Earth, but it also challenges us to consider what life may be like elsewhere in the universe. Could there be societies that function in entirely different ways from one another? The telescope's remarkable capability to detect infrared light played a key role in identifying the unique heat patterns of Proxima Centauri B. This finding is pivotal, as it deepens our understanding of the planet's atmosphere. Scientists now plan to leverage this technology further to study the atmosphere in greater detail and explore the possibility of life on the planet. Its proficiency in detecting infrared light makes it especially effective for observing Proxima Centauri B during nighttime. This telescope can detect even the smallest glimmers in space, whereas others have trouble picking up on dim light. Because of this, it's the ideal instrument for verifying if artificial light may exist on the planet's dark side. The telescope's frequency range is extremely restricted compared to that of natural starlight and is intended to detect artificial lights in space within that range. The planet and star have an intriguing interaction. Solar panels may collect a lot of energy while facing the star, and scientists are also interested in the light that bounces off these panels. Like Earth, it experiences day and night cycles while circling its star. The nights are bitterly cold, while the days are intensely hot. But the most striking feature isn't just the extreme temperatures. It might lack an atmosphere. This absence explains the drastic temperature swings. Without an atmosphere to retain heat, temperatures plummet sharply after a scorching day. Astronomers find these extreme fluctuations fascinating, as they could reveal clues about the presence or absence of an atmosphere. The telescope's cutting-edge infrared imaging makes it ideal for examining the planet's heat and providing important information about its atmosphere. The fact that the telescope's orbit precisely aligns with its own orbit makes it much more remarkable. This implies that it will be able to observe the day-night cycle of the planet up close once every 11 plus 2 Earth days. The next stage would be to investigate its contents to discover if it might support life. If it had an atmosphere, methane, oxygen, and water vapor would be strong indicators that life may be present in that area. It would be highly suggestive that it might have conditions conducive to life if these were discovered. Collecting and analyzing light from the planet's atmosphere is no easy task. While its primary function is to measure elements like water vapor, carbon dioxide, and methane, and it is equipped to do so, this data is crucial for understanding the planet's environment. Although it struggles to detect bonded oxygen, a vital marker in the search for life, it continues its diligent efforts, tirelessly scanning the skies. It does, however, monitor other significant components closely, such as ozone, which provides valuable information on how robust an atmosphere a planet may have. Scientists are becoming more and more excited about learning the mysteries of distant planets as they examine the data from this telescope. We are getting closer to the answer to one of the greatest mysteries of all with each new piece of knowledge. Is Earth the only location in the cosmos where life exists? It is limited to observing a small number of reasonably nearby planets at this time. In order to conduct a more thorough examination of these far-off planets, focus is shifting to more sophisticated instruments, such as the Extremely Large Telescope, which is scheduled to start operations by the year 2028. By providing a far more in-depth view of these planets, this new telescope will aid scientists in determining whether or not they are potentially home to life. The data being collected is transforming our understanding of the cosmos. While it is already doing incredible work, the insights we gain today will not only reshape our view of the universe, but also shape the future of space exploration. Future space telescopes will use techniques to block out the dazzling light from distant stars, much like shielding our eyes from the sun, with a hand to see more clearly. This approach will help scientists detect faint reflections from planets and analyze their atmospheres to assess their potential to support life. However, distinguishing between gases produced by natural processes, such as volcanic eruptions, and those generated by life forms, remains a significant challenge. Now that these fascinating results have set the stage, we can focus on how these findings will influence our future exploration of the cosmic unknown. James Webb's contribution to the search for extraterrestrial life is significant. Scientists are putting a lot of effort into enhancing their techniques for distinguishing between these signals, which will facilitate the search for actual signs of life. But discovering life is not the only goal of this quest. It also aims to discover more about these far-off worlds. We are currently seeing early peeks of what future space explorations may find, thanks to the James Webb Space Telescope. Each new finding expands our understanding of the cosmos and challenges what we already know. For as long as humanity has existed, we've wondered whether we're the only species in the cosmos. Today, a powerful telescope is being used to explore different regions of the sky in search of signs of extraterrestrial life. With growing support for the idea, scientists are dedicating considerable effort to proving that life exists beyond Earth. The search for extraterrestrial intelligence, SETI, was initiated in 1984 by American astronomers Jill Tarter and Thomas Pearson. They established a non-profit organization to use the 42 dishes of the Allen Telescope Array, located in the foothills of California, to search for radio signals from space. These signals are an important tool in the hunt for life because they can travel over long distances with little interference. SETI has been listening for signals from extraterrestrial civilizations for more than 30 years, but hasn't heard anything distinct. However, Jill Tarter doesn't give up hope. She believes we are closer than ever to making a groundbreaking discovery, thanks to today's advanced technology. Tarter envisions this effort expanding into a global mission, uniting people with the shared goal of finding extraterrestrial life. Recently, the scientific community has been buzzing with excitement over a new NASA report, suggesting that the telescope may have captured something as incredible as city lights on a distant planet. Located 1 million miles from Earth, the telescope enables us to explore the cosmos in ways never before possible, offering unprecedented insights into the universe. The purpose of this telescope is to detect objects that were previously invisible. It helps scientists understand how galaxies, stars, and planets are formed. Now that it has a high-tech camera and specialized filters, astronomers can examine the colors surrounding far-off celestial bodies in greater detail. These instruments allow them to study various light wavelengths and get knowledge about the chemical and physical composition of planets and stars. It searches for indications of life in the atmospheres of other planets, in addition to just looking. Thanks to the telescope's unparalleled capacity to explore the depths of space and time, significant discoveries have been made. The discovery that the cosmos has far more mass and massive galaxies than previously believed by astronomers is among the most unexpected. They must now reassess their theories about the origins and expansion of the universe. Each new discovery made through telescopes fuels our curiosity about extraterrestrial life and deepens our understanding of the potential for life beyond Earth. As we advance in space exploration, we gain new perspectives on distant regions of the cosmos. What's fascinating, however, is that with every new revelation, even more questions begin to emerge. About 20 years ago, the space beyond our solar system was mostly unknown. We had very little knowledge about the planets circling other stars. As of right now, more than 4,000 exoplanets have been discovered by scientists. This illustrates exactly how far we've gone in both our curiosity and technology. NASA, a leader in space exploration, believes this is only the beginning. They estimate that there may be trillions of planets in our galaxy alone. Each with its own secrets, fuels the unwavering desire to investigate space and learn more about the universe. Scientists continue hunting for any indication of life beyond Earth, and sometimes they get incredibly close. A significant event occurred when the Galileo spacecraft circling Jupiter discovered evidence pointing to the possibility of plant life on a distant planet. This was a truly important finding. A biosignature, essentially a hint that life may exist, was discovered by scientists. It was the vegetation red edge, a method of identifying plants by their light-reflecting characteristics. In light of this, telescopes are now prepared to go far beyond simply finding planets in the habitable zone, the precise location orbiting their stars where circumstances can sustain life. Furthermore, new techniques like the virtual reality engine may fundamentally alter the way we search for planets that may harbor intelligent life forms in addition to basic ones. The fascinating aspect of this next phase of space exploration is its aim to explore the vast, uncharted regions of the cosmos. Picture sunlight shining through the atmospheres of distant planets, splitting into different wavelengths. The atoms and molecules in these atmospheres absorb these wavelengths, creating unique patterns known as spectral signatures, cosmic fingerprints that scientists examine to assess the potential for life on these distant worlds. When a planet passes in front of a star, scientists believe telescopes can capture the light filtering through its atmosphere, helping to analyze the composition of distant planetary atmospheres. Planets similar in size to Earth often have atmospheres made up of carbon dioxide, nitrogen, and oxygen. While life could exist on some of these planets, the discovery of unusual or unique compounds might suggest the presence of more advanced life forms or even intelligent civilizations. Chlorofluorocarbons, for instance, are man-made chemicals primarily used in cooling systems. Their detection on another planet might indicate the presence of intelligent life. If the James Webb Space Telescope finds them, astronomers will have new opportunities to investigate planets, atmospheres, and consider the potential for extragalactic life. The next segment of exploration will examine how these technological wonders could revolutionize our investigations. As we continue our journey, thinking about life beyond Earth brings limitless possibilities, many of which are vastly different from life as we know it. We tend to picture life thriving in stable, moderate environments, but the truth is often much more unpredictable. Consider extremophiles, tiny organisms that challenge our ideas about where life can exist. They are capable of surviving in environments with extremely low pH levels, as low as 3, or at scorching temperatures above 250 degrees Fahrenheit. Their remarkable resilience shows just how adaptable life can be, even in places we would typically deem uninhabitable. This is just the beginning. Uncovering life in these peculiar places could transform our understanding of the universe. As we search for planets that might host life, we're only beginning to grasp the full scope of human potential. Space exploration is vast and complex, demanding a thorough and expansive search for extraterrestrial life. A great starting point is planets like Earth, orbiting stars similar to our Sun. However, it's also important to remain open-minded and explore less conventional areas. For instance, exoplanets orbiting red dwarf stars, which are plentiful in the universe, present unique conditions that could support life. Though not as bright or warm as our Sun, red dwarfs offer extended periods of stability, giving life ample time to evolve. The TRAPPIST-1 system is an excellent example of this, with 7 rocky planets orbiting a weak red dwarf star. 3 of these planets may have liquid water, which is essential for life as we know it, because they are located in the habitable zone. The TRAPPIST-1 star produces enough light to possibly support life, despite being smaller and colder than our Sun. Scientists are analyzing this light to learn more about what it might be like to dwell on one of these worlds. This system, located in the constellation Leo, around 41 light-years away, is a fascinating site for ongoing investigation, thanks to the JWST. These findings have NASA scientists, such as Ward Howard, very excited. He leads a team at the University of Colorado Boulder, focusing on studying planets orbiting other stars, particularly those with atmospheres similar to Earth's. Gaining knowledge about stars aids in understanding the planets surrounding them. Although TRAPPIST-1 is fascinating, it's not the only star worth keeping an eye on. Proxima Centauri, located just 4.5 light-years away, is our closest stellar neighbor. However, its dimness makes it hard to spot in the night sky. For a planet to support life, it would need to orbit much closer to Proxima Centauri than Earth does to the Sun. In an exciting breakthrough in August 2000, a planet roughly 1/3 the size of Earth was discovered within Proxima Centauri's habitable zone. Proxima B, a planet orbiting Proxima Centauri just 4.6 million miles away, receives just the right amount of sunlight to melt ice and create conditions that could potentially support life. However, the planet faces harsh environmental challenges, such as intense solar winds that could gradually strip away its atmosphere. Despite these conditions, Proxima B's exposure to sufficient sunlight keeps its surface warm enough to maintain liquid water in its seas. This warmth could foster life. But since Proxima B is tidally locked to its star, one side is perpetually bathed in sunlight while the other remains in darkness, creating 2 very different environments. Though its size is modest, the energy emitted by its star may be enough to support life, potentially even life forms similar to those on Earth. Do you think the JWST has detected evidence for terrestrial civilizations? Or are we just interpreting what we want to see? Let us know your thoughts in the comments, and don't forget to like and subscribe.